The standard history of physics begins in Europe. We are taught that Isaac Newton codified the laws of motion, John Dalton defined the atom, and Benjamin Franklin proved the electrical nature of lightning. However, weathered Sanskrit manuscripts written thousands of years before the European Enlightenment contain descriptions of those same physical laws. For centuries, these texts were categorized as religious philosophy or poetic mythology. Researchers are now finding that this language often obscures a highly specialized system of empirical physics. Decoding the science requires looking past the poetic imagery of the hymns and sutras to find the technical vocabulary used for measurements and mathematical formulas. Reading these records carefully reveals a timeline of discovery that challenges our understanding of how and when the laws of nature were first recorded. Around 600 BCE, the philosopher Acharya Kanada observed that physical matter, like a grain of rice, can only be divided so many times before reaching a final point where it can no longer be broken down. He identified this indivisible, eternal building block as the Anu. His texts detailed how these individual particles bind together to form diatomic and triatomic molecules, concepts he outlined 25 centuries before John Dalton's work in the 1800s. This record correlates Isaac Newton's laws of motion with Kanada's Vaisheshika Sutras. Kanada's first sutra, change of motion is due to impressed force, defines inertia 2,000 years before Newton. The second and third sutras similarly describe motion proportional to force and equal opposite reactions. These fundamental mechanics were explicitly codified in ancient Indian philosophical texts long before they were ever published by European scientists. In the 11th century, the mathematician Bhaskaracharya contributed to the Surya Siddhanta, a treatise on astronomy. He used the term Gurutva Karshan Shakti to define gravity as an incredible, attractive force that keeps the spherical Earth in orbit and causes objects to fall to the ground. The Rig Veda allegorizes light by describing the sun god Surya riding a chariot drawn by 7 horses, representing the 7 rays of the visible spectrum. Decoding the actual speed of light requires translating 2 specific Vedic units from hymn 150, the yojan for distance and the nimisha for time. The verse states sunlight travels 2,202 yojans in half a nimisha. That is roughly 19,818 miles in 0.11 seconds. This results in a speed of 185,000 miles per second, nearly identical to the modern measurement of 186,282. The Agastya Samhita even provides a blueprint for a wet cell battery, detailing functional layers of zinc, copper, and mercury inside an earthen pot to generate a charge. These specific measurements of light and designs for energy storage demonstrate that these ancient scholars used a precise, quantitative system to analyze physical forces. Reaching this level of precision without modern instruments suggests a different approach to research. Vedic scholars practiced tattva jnana, or the unified study of reality. These researchers treated acoustics, biology, and engineering as an interconnected system. This diagram illustrates that alignment. The Vena's 24 frets correspond directly to the 24 cartilages of the human spinal cord, linking the physics of sound to human anatomy. This rigorous empirical logic is often buried under layers of ritual and traditional storytelling. Decoding these ancient records offers a map of human ingenuity, showing the foundations of physics were drafted thousands of years before the modern era.